Hey guys, this is Molecular Structures Part 1, just drawing the structures from the valence electrons. Alright, so on every page I've got the Lewis dot structure rules and exceptions typed out. If you don't have them written down in your notes or somewhere yet to where you can follow along with them, I would pause the video now and have them written down somewhere. Make sure you understand what each rule is. So we're going to go through those real quick. First one is you count the total number of valence electrons, and to do that you add the valence electrons for each atom together for the entire molecule. You get the number of valence electrons from the group that they're in. So, like for example, chlorine is in group 17 on the periodic table, so it has 7 valence electrons. Carbon is in group 14, so it has 4 valence electrons. You can also get the valence electrons from the electron configurations, but that's unrealistic. You don't want to have to write out the electron configuration every time, so you can just look at the group numbers. All right, and then next, rule 2, make the first atom listed your center atom. And so all of the Lewis structures that we're going to draw starting out are only going to have one central atom. The only thing that cannot be a central atom is hydrogen. And hydrogen cannot be a central atom because hydrogen electron configuration is just 1s1. And so there's no p orbital in the first energy level, so it could never hold more than 2 electrons anyways. All right, and then we're going to put all the other atoms around the central atom. Next, we finish the octet rule for the outer atoms first. And so the octet rule down here, the octet rule, elements must fill their outer s and p orbitals. And so s can hold 2 electrons, p can hold 6 electrons, and so you add those two together and you get 8 electrons total. And we'll talk about the exceptions after we do some examples where everyone is just, all the molecules are following the octet rule. All right, and so after we've finished the octet for the outer atoms, we distribute the remaining electrons around the center atom. We check to make sure that all of the atoms are completely satisfied with the octet rule, and if it's not, then we'll make double or triple bonds. So let's start from the beginning and start with some easy ones first. And so first we have to calculate the number of valence electrons, and so carbon is in group 14, so it has 4 valence electrons. Hydrogen is in group 1, and so it has 1 valence electron, but we've got 4 hydrogens, and so each hydrogen will have 1 valence electron. And so if we multiply first, 4 times 1 is 4, plus 4, that is 8 valence electrons total. All right. And so after we've done the first step, we're going to do number 2. And so we're going to put carbon in the middle of our molecule. And so carbon is going to go in the middle. And then we're going to put hydrogen around carbon. And we're going to go ahead and bond it in. So I'm going to move this. Let's see. Move it all up and shrink that down a little bit. All right, so we're going to bond in the carbon, or bond in the hydrogens to the carbon. So 1, 2, 3, 4. Now, each bond has 2 electrons in it. And so those electrons in that bond right here are being shared back and forth between carbon and hydrogen, and that's what holds the atoms close together and forms the bond. And so the electrons in there are just doing that back and forth. And there's 2 of them. So right now I've got 2, 4, 6, 8 electrons. So I've used all 8 of my valence electrons, and now I have to check to see if the octet rule is satisfied for the outer atoms first. And so because hydrogen can only hold 2 electrons, right? Hydrogen can only hold 2 right here, can only make 1 bond, and that's it. They're happy. All right, all the hydrogens are completely fine. Now the carbon in the middle has to have 8, just like everything else, and it's got 2, 4, 6, 8, because remember there's 2 electrons in each bond, and so carbon's octet is satisfied as well. And so this is the structure for CH4. That's it. All right, let's go to the next one. And so the next molecule we have is NH3. And I'm just going to shrink these rules down a little bit because we don't need as much space this time. This is our second time around. And I'm going to move this guy over here. All right. So first we have to calculate the number of valence electrons. And nitrogen has 5. And hydrogen has 1, but we have 3 of them. So 3 times 1. So that's going to be, again, 8 valence electrons. All right, now after we have the number of valence electrons, we have to do number 2. Make the first atom listed your center atom. And so nitrogen's going to go in the middle, and then we have to surround nitrogen with the rest of the atoms and bond them in. So we've got 1, 2, 3 hydrogens, right? Because there's only 3 hydrogens, so we draw 3 of them. And then it says distribute remaining, or I'm sorry, number 3, finish the octet rule for the outer atoms first. The outer atoms are hydrogen, and hydrogen can only do this. That's all it can do. Hydrogen can only make this 1 bond, and that's it. Okay, so we can't put any more dots on hydrogen or anything. Number 4 says distribute the remaining electrons around the center atom. So I've got 2, 4, 6 electrons around nitrogen, so I still have 2 more electrons left from the 8 that we counted. And so I'm going to put them right up here. All right? And those are called a lone pair of electrons. Okay, lone, like the Lone Ranger. So they're a lone pair of electrons. And so now we're going to check to make sure the octet rule is complete for all the atoms. Number 5. So I've got 2, 4, 6, 8. So nitrogen is good, and hydrogen is good. And so this molecule is finished, and that would be the answer for the structure of NH3. All right, next we've got HCl. So shrink that down, move this over, and first we have to count the number of valence electrons. And so hydrogen has 1 valence electron, and chlorine has 7. And so that will be a total of 8 valence electrons. I'm going to put chlorine in the middle because hydrogen can't be there, even though it wouldn't matter in this molecule. But I'm going to put chlorine in the middle, and I have to bond hydrogen to it. So 1 hydrogen and 1 chlorine. So I've got 2, and then hydrogen is done, so I have to put the rest of the electrons on the inner atom, the center atom, which is chlorine. So I've got 2, 4, 6, 8. And so chlorine is finished. It's got 8, hydrogen has 2, and so this is the structure for HCl. All right, next we have sulfur trioxide. And this one's going to be a little different. And so sulfur has 6 valence electrons, and oxygen also has 6 valence electrons. So we've got 6 plus 3 times 6 because we have 3 oxygens. And so that's 18 plus 6, that's 24 valence electrons. All right, so sulfur will go in the middle, and then I have to add in 1 oxygen, 2 oxygens, 3 oxygens. And so out of the 24 valence electrons, I have used 6 so far. After you put all the atoms around the central atom, right here. We have to finish the octet rule for the outer atoms first. Now, we didn't have to do this in the past 3 structures because hydrogen were the outer atoms and all it can do is bond. But oxygen has to have 8 valence electrons. And so we have to count those in. So we've got 2, 4, 6 in the bonds. And so now I'm going to put 8, 10, 12, 14, 16, 18, 20, 22, 24. Now once I've done that, I've used all 24 valence electrons, right? So I don't have any more, okay? And it says, number 4, distribute remaining electrons around a center atom. Well, I don't have any more to put there. Number 5 says, check to make sure that the octet rule is complete for all atoms. And so if I go and look, these oxygens are fine because they've got 2, 4, 6, 8. This one has 2, 4, 6, 8. This one has 2, 4, 6, 8. But sulfur only has 2, 4, 6. And so sulfur's octet rule is not satisfied. And so since it's not satisfied, it says if the octet rule, this is number 6, if the octet rule is not complete, make double or triple bonds where needed. And so sulfur won't stay in this relationship if the octet rule can't get satisfied. And so it is going to have to get electrons from one of these oxygens that's hoarding them. All right, and so what happens is oxygen then will donate. It doesn't matter which oxygen you pick, just one of them has to donate to share an extra pair of electrons. So it's going to end up moving its electrons into a bond instead of them being up here. And so those electrons come down here and form a double bond, and so they're going to go away right here. Okay, so we're going to erase them right here. And instead of them being just on oxygen, they're now also being shared between the sulfur and the oxygen. So there's 4 electrons here being shared now instead of just 2. And so that is called a double bond. Let's see, what color do I want to use? So that is a double bond. And so there are 4 electrons there. Okay, and so now if we go and we check the octet rule again, we've got 2, 4, 6, 8 for sulfur, 2, 4, 6, 8 for oxygen, 2, 4, 6, 8 for oxygen, and 2, 4, 6, 8 for oxygen. And so this is the correct structure for SO3. All right, PS2 minus. So I'm going to move that over here, move this over here. And P, phosphorus, has 5 valence electrons. Sulfur has 6 valence electrons, so that's 2 times 6 because we've got 2 sulfurs. And then we've got a negative charge. Well, we're counting electrons, and electrons are negatively charged. So if this has a -1 charge, then we have to add 1 electron to it. And so altogether here, we end up with 18 valence electrons. And I'm going to put phosphorus in the middle, and I'm going to bond to it 2 sulfurs. So I've used 4 of the 18 valence electrons in the bonds. Now after you put all the atoms around the central atom, you have to finish the octet rule for the outer atoms first. And so I'm going to put I'm going to fill up the octet on the outer atoms first. So I've got 2, 4 in the bonds, and then 6, 8, 10, 12, 14, 16. Now I still have 2 left. So it says Number 4, distribute the remaining electrons around the center atom. So I've got 2 there. And so that's all 18 electrons. Now we have to check to make sure the octet rule is complete for all atoms. So I've got 2, 4, 6, 8 for that sulfur, 2, 4, 6, 8 for that sulfur, but phosphorus only has 2, 4, 6. And so since phosphorus's octet rule is not satisfied, we have to make double or triple bonds. And so one of these sulfurs, again, is going to have to share an extra pair of electrons. So I'm going to pick this one this time to go down here and double bond. So there's a double bond there. And the electrons are going to have to disappear here because they've moved over. And one more thing about ions, when we use those, we have to put brackets around the molecule and put the charge on the outside. And that's because if you draw this without having the formula on something, if someone was to count the number of electrons without the brackets and the charge, they wouldn't realize where the extra electron came from. And so that's just to represent the charge correctly. All right, next is PF5. All right, and so this one is different. Again, we're going to have 5 valence electrons for phosphorus, and then we have 5 fluorines, and each fluorine has 7 valence electrons. And so that's going to equal out to be 40 valence electrons. And so I put the first atom listed down first, and then I'm going to put the the fluorines, excuse me, in. And so I've got 1, 2, 3, 4, 5. There's 5 fluorines in the molecule, and so I need to draw 5 fluorines on phosphorus. Now, when I look at this, it looks weird because when you count the number of valence electrons around phosphorus, it's got 2, 4, 6, 8, 10. And we've only talked about an octet rule, and that's 8. So I want to look at sulfur's electron configuration real quick, or we can use phosphorus. Let's use phosphorus. So phosphorus electron configuration, 1s2, 2s2, 2p6, and then 3s2, 3p3. So that's all fine and dandy, but when we look at what orbitals are available, so if this is N, we have an s orbital available when n is 1, there's an s and a p orbital available when n is 2, and then there's an s, a p, and a d, and d orbitals available when n is 3. But there's no d here, right? It hasn't been filled. So it has an empty d orbital. Empty d orbital. And because of that, it can use the empty d orbitals to store electrons in. And so they can actually use it to bond if they need to. And so that's what's going on here. So as long as it's in the 3rd period of the periodic table or lower, it can hold up to 12 valence electrons. Some of them can hold even more, but you won't see any of those in my class. So we have to continue now with the rules, okay? And so we've only gone through step 2, only gone through to step 2. So we have to finish the octet rule for the outer atoms before we can do anything else. And so I've used 2, 4, 6, 8, 10 of the 40 electrons. And so now I'm going to start distributing on the outer ones. So I've got 10. Let me make this a little bigger. 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. And so that's all the valence electrons, and everyone's octet is complete, right? There's 8 here, there's 8 here, there's 8 here, 8, 8, and then phosphorus has 10, which is fine for phosphorus. All right, let's do one more. This one is xenon dichloride. And so xenon has 8 valence electrons. Whoa, that's big. Let's make that a little smaller. Xenon has 8 valence electrons. Chlorine has 7 times 2. What am I doing? 7, not Cl, times 2. And so 14 plus 8 is going to be 22 valence electrons. And xenon will go in the middle. And then we're going to bond in the chlorines on the outside. So I've got 2, 4. Now I have to put the electrons on the outer atoms first. So 2, 4, 6, 8, 10, 12, 14, 16. Now the rest go on the inner atoms. 18, 20, 22. Now remember, they come in pairs, and so it's going to look like that. You wouldn't draw 3 electrons on the top and 3 electrons on the bottom. They need to go in pairs. So 2 and 2 and 2. Now you could put 2 pairs on the bottom and 1 pair on the top. It doesn't really matter. But now we have to check the octet rule. There's 8 around chlorine, and 2, 4, 6, 8, 10 around xenon, which is fine because xenon is below the 3rd period on the periodic table. All right, so that's it for this video. If you have any questions, please let me know. A lot of this just takes practice and seeing where you make mistakes so that you don't make them. Many students forget about double bonds, so please make sure you're checking the octet rule to make sure that it's complete and sharing electrons when you need to. One last thing, a big, huge thing that students do not do correctly is double and triple bonds. Whoa, what's happening? Are only used when you don't have enough electrons. So if you have extra electrons, they go on your center atom. They do not make double or triple bonds. You only make double or triple bonds when you don't have enough. All right, good luck. Keep it up. You'll get it eventually.